Hi, everyone. I'm very happy to be here. My presentation will be a bit of a short one because today I'm lecturing for like 8 hours straight. It's one of those days. So yeah, happy to meet you. My name is Stylianos. You can call me Stelios. I'm a data scientist, AI expert, and economics expert as well. You can find more about me on our website. I was one of the first researchers in the area of tokenomics, the first one to propose the use of agent-based modeling, and I'm still doing research in this area. Uh, my current interests revolve around tokenomics auditing, but I'm also involved in other types of research and work and consulting. In the last 12 months or so, I've done lots of work with Goracle to set up part of their protocol. Okay, part of the protocol is, to be more precise, part of their fees structure. Okay, and incentives around how fees are working in Goracle. So the topics that we're going to cover is, first of all, what is an oracle, then what are the participants of an oracle, what Goracle does, the ecosystem, and what were some of the challenges and how we solve them. Okay. So for those of you who are new to the world of oracles, decentralized oracle is essentially a platform that provides data, okay, to other blockchain projects and layers. So the reason we need oracles is because in a decentralized world, it's not easy to trust centralized feed providers. You need to have a decentralized solution. Okay, it's as simple as that. And a decentralized oracle relies on what we call node runners. Okay, so there are certain, let's say, computational entities which are responsible for making the whole system work. Okay, they aggregate the data, they provide access to the data through APIs, etc. And so one of the most important considerations for any oracle is the economics. Okay, how can you create a structure, a free structure which works and doesn't overcharge, but also leaves enough profit margin so that it's actually incentivizes adoption. And another challenge is that because data streaming services, there's usually need for them to be what's the best way to put this? They're essentially 24/7, right? There are many use cases in data streaming which require a constant and continuous stream of data, which means that it is important that there is some element of predictability around the fee structure and the cost associated with it. And obviously, the volatility of the crypto market doesn't really help with that. So blockchain oracles are entities that connect blockchains to external systems, and then thereby enabling smart contracts to execute based upon inputs and outputs from the real world. So you can see here a conceptual representation of how the system works end to end, where you have feed providers, then you have the provided data, that is, then the node runners, which they are the entities that really make the system work, like the workers of the oracle. And then on top of that, you have the computational layer. Okay, so you have the smart contracts, which enable what is effectively a peer-to-peer database, and then finally an application front end. Okay, and here are the different participants of the ecosystem, the different agents, let's say, the customers, obviously, where the end customer can either be a user or a company, pretty much anyone who needs to access a data feed. Then the feed providers, and these are the entities that provide the data. The node runners / validators, we call them validators as well because they have to validate the quality of the data. And then the community members, where community members is a bit of a broad definition and essentially involves, and this definition involves anyone who participates in the ecosystem. Okay. Sorry. Okay. So how the ecosystem works. So a consumer requests data for the smart contract. Okay. So the data, for example, can be the price of Bitcoin, the price of Ethereum. Okay. And then the node runner's job is to pull data from API endpoints and aggregate the data. And then the data point is voted on by a committee of validators. okay, that ensures that the data point is correct. So in a very simple model of fees for an Oracle, you can just use the native token, Gora, to pay for the fees. And then the fee could be determined by the node runners, and you have effectively some like a market, and then you just let the market decide. However, there are certain issues with that model. So first of all, such a model is quite centralized because there's not an infinite number of node runners, which means that you can face many of the problems that exist in a free market, such as cartels, monopolies, oligopolies, and then you just replicate some of the issues that exist in the fiat world on a blockchain, which is obviously not a desirable outcome. A disadvantage would be that obviously there could be certain elements of market failure, right? And again, this is not something that we want. And finally, another issue is the potential volatility associated with the crypto markets. So imagine a world where someone has to sorry, tweet back channel. Okay, first sequence question. Sorry. Yeah. So imagine, for example, that a company is using this service and they know that there's an associated cost of $1,000 every month. And then the crypto market experiences very wild volatility. And then the USD value of the Gora token, like the value of the Gora token denominated in US dollars, fluctuates every day like crazy. Okay, then suddenly the cost goes from $1,000 to $10,000 a month, then to $500. Okay, that's obviously not a desirable feature. So we created a method, we created an algorithm to overcome this. And this takes place through a combination of, this change takes place through a combination of governance and algorithmic and protocol constraints. So we start by setting the fee, by setting a fixed fee for all data requests. Okay, so all the node runners, they have to play on a level playing field. And then we create a model where the fee, the next fee that the consumer pays, is based on some kind of a smooth version of the historical fees. So essentially, the way this works is that we start with a fee, and then the then the community and the nodes, they can vote to make some adjustments to the fee based on price volatility. However, these adjustments, they are restricted, they can only take place within certain constraints. And these constraints are determined by a smooth version of the fees and the price, okay? Which means that we try essentially to manage different incentives, okay, and different motivations. So on one hand, the node runners, they can extract some additional profits, so they can vote to increase prices if the market is actually okay with this, because, you know, it can, increasing profit can make the protocol more popular, it can attract more node runners. However, these increases, they cannot be the types of increases that you would see, for example, in an oligopolistic scenario or a monopoly. Okay, simply because the protocol says, look, based on the recent history of price movements, you can only like change the price of the fees within by that amount. Okay, and this essentially is what enables a sort of regularity and predictability as to where the fees can go. So on top of that, we made sure that this works by conducting various simulations. So we use data from Chainlink, which is the most popular Oracle right now, but that's an Oracle for Ethereum, whereas Goracle is a protocol for built on Algorand. So that's like essentially the market need that Goracle covers. It's an Oracle for Algorand. And we're in various simulations to understand how the historical, let's say, if for example, the Gora token would experience the same degree of volatility that Chainlink experienced, how much the fees could change in the different circumstances. And obviously, this gives some reassurances to the users, to the end user, be it individuals or companies, that the costs are always going to be bounded to, to a certain range. As well, giving some reassurance to the node runners, those who participate in the community, that they actually can make some profit by participating in the protocol. Again, I think probably, I'm not sure if we need to expand upon this, but maybe, okay, it's good to mention this. And then here's like some other hacks that we incorporated. So we restrict the price. Okay, what I just described was essentially the first point, restricting the price within a certain range in fiat terms. We allow the fees to also be paid in stable coins, okay, um, which essentially, it can create some issues, but opens up the market. And then also another solution is introducing something which we call discount tokens, where essentially someone can buy, can stake tokens, okay, and essentially they get some kind of special offer which guarantees the price for uh, which guarantees that they pay a particular price for a feed over a period of time, which, let's say in more traditional financial terms, it can work a bit like a futures contract for information. So like in the derivatives market, you can buy a futures contract because a year from now, you're going to rise to be at a particular price. We're essentially proposing something similar, but for the information provided by the feeds. Okay, so this is like where the solution stands. Goracle has already launched, but it's still like early stages. So if you want to know more about this, make sure to visit the website. And we're still working on optimizing this solution, getting feedback from real users, getting the feedback from the node runners, and see how we can further optimize the parameters of this system. But we're quite proud of what we've done because it's like the only, let's say, system of this kind in existence. Okay, so for example, we're doing something which we believe is much better than Chainlink and existing solutions out there. And yeah, that was more or less it. I hope you found this useful and interesting.